Um, we are here today to work on the exponentially weighted moving average estimate of variance. Actually, what we're going to do is generate the variance-covariance matrix for the underlying equities in our portfolios. So we're starting this one once again from the portfolio analysis spreadsheet. And then what I've done is just, again, you're going to go to File, do the Save As, and then I've saved it as RRB. So this is actually the value at risk and rebalancing of portfolios. Okay? I don't want to do that. Cancel. So the idea behind exponentially weighted moving average is that, as stated in the textbook, is that as time goes forward, the risk in the market changes. It can go up, it can go down. We call this conditional risk because it's a function of the underlying economic conditions, political conditions that happen to be going on at the time. The long run risk, like if you're investing over 20 years, is probably fairly stable. It's just the conditional risk. As time goes forward, the next month may be less risky, the month after that may be more risky. So we want to focus on trying to do this relative to by using the exponentially weighted moving average regression or methodology. Alright, so our first step is to create a base variance covariance matrix. And what I mean by base is this is the starting point of where we're going to do our exponentially weighted moving average. Our EMW analysis for my series of stocks is going to be based on a lambda of 0.95. And I'm going to go over a little more detail why I pick lambda of 0.95 later. And we're going to base this on 80 days of, here's my number of days, 80 days of evaluation. And some people in class, for example, Jonathan, might say, well, how did I pick 80 days? And the answer to that's pretty simple. Exponentially weighted moving average basically encapsulates historical volatilities to make a prediction of what the current volatility is. And with a lambda of 0.95, I'm just going to do it right down here because I can. 0.95, and we're going to raise that, meaning exponentiate it, to the power of 80, so 80 days. And you can see that we're here at 0.165, which means the variance from 80 days ago is contributing at most 0.16 or 1.6% to today's calculation, which is relatively low. As you expand the number of days, the contribution simply goes to zero. And that's one of the ideas of this moving average calculation. Obviously, if we come back here and we decrease, say, our lambda coefficient to 0.5, we go basically to zero, right? So this is raised to the negative 25th power. So as lambda decreases, the number of days that you want to incorporate into your analysis is going to also decrease. As lambda increases, you're putting more and more weight on today's volatility, but you're also incorporating more of yesterday's volatility into the calculation. So the first thing we need, and I'll show you how to do the freeze panes here in a minute, which is why this stuff isn't moving, is the base variance that we're looking for. And how do you calculate the base variance? Well, that's this variance covariance matrix over here. And what I've done, I'm going to pause this just for a second because apparently my dog is having some problems. Okay, back. So we all know how to do this. We've done it before. What we're going to do is come to our returns. And what I've done here is added accounts for the number of days just to make it easier to follow. And I'll show you now how to freeze panes. You notice as I move down, my 3M, DD, UPS, Home Depot, Procter & Gamble, and Spider stay up there, which just makes it easier to follow. You'll go into the View tab, and you'll see here where it says Free Panes. I'll go ahead and unfreeze them. You'll notice that light gray line has disappeared. So you just pick a point that you want to freeze. I'm going to do, say, this spot, and go ahead and freeze my panes. Now as I go down, I'm locked in at 2, and if I move over, like so, this first and second columns are always going to be there. Alright, so I'm going to go back and unfreeze my panes, and then go ahead and freeze them again just so it's easier to follow. Alright, so at this point we're good to go. So the variance covariance, what we're going to do is we want 80 days in the analysis, as I mentioned, because of the power function. So we're going to go from day 81, and we're going to add twice that, or 160 days, to the analysis. So you'll go into data, just to remind you, data analysis, covariance, click OK. We'll highlight the data that we're interested in. As a matter of fact, I'll just go ahead and do it. So we're going to go from day 81, and then 160 plus 80 is going to be 240. So we zoom down here to 240. And I've mentioned several times that there's mathematics of finance and art of finance. Your selection here in terms of number of days for your base variance covariance analysis is part of the art. I'm picking 240, but you could easily pick a completely different number and mathematically still be correct. Alright, and then my output range, I'm going to select, in this case I'm just going to go ahead and add a new worksheet. We'll hit OK. So here's my new worksheet and my variance covariance matrix. You'll notice that it has numbers up top and numbers down the side. These represent the different variables that we're looking at. So we would just adjust this and add in 3M, and then DD, and etc., etc. So I'm not going to go ahead and finish that because I already have it done. We'll delete that sheet, not a problem. And this is my base variance covariance matrix. And again, it comes in as a diagonal, so I do the copy and paste to move it across. Now, the next thing I want to do is create my EWMA, which is the exponentially weighted moving average. I've set my numbers up. These numbers at the top represent the variance and covariance that come from the base matrix here. And frankly, the easiest way to do this, let me go ahead and insert another sheet and start to build it for you, is we're just going to come down a little bit and going to say that this is equal to, and go to the base covariance, pick the first one, and we're just going to drag it across. And once I see the zeros, I know that I've gone beyond the matrix, and drag it down. I see more zeros, so we can go ahead and delete these guys and delete these guys. Now remember, the ones on the diagonal are the variance. So if I put my 3M and then DD and UPS and Home Depot and Procter & Gamble, then we're going to move the diagonals above each one of these guys, and like so. I gotta pick it to move it. the next diagonal, and the last diagonal. And the next thing we're interested in is the covariance matrix. So here it's going to be MMM relative to DD, and then MMM relative to UPS, and then MMM relative to HD. I typed this one in wrong. HD. And all I'm doing is I'm picking the first one and then slashing the next group. So the last one here is going to be MMM relative to PG. That's a page down. And then you just skip down one. So it's going to become DD relative, and then move one down UPS. And then DD relative to Home Depot. And continue on. The next one would be DD PG, and then UPS HD, UPS Procter & Gamble, and the last one is Home Depot and Procter & Gamble. Because Procter & Gamble versus Procter & Gamble is just the variance, which we already have up here. And then you'll move each one of these individual blocks. Notice how I'm going in order. So the column represents 3M up top, and then we go down the list. The variance is the first one, and over, and repeat the process. So that sets up our top. Delete that, and I'm going to go ahead and kill this sheet too. Alright, so this is my variance, this is my covariance, my lambda is being set to 0.95. As I mentioned, here are the variance values. If we go back to our base variance, correlation, those are the ones on the diagonal, and then these covariances you can see are coming down the column, down the column, and finally the last one. Alright, so that sets up the top of this. Now we want to do is configure the rest of it. So I've added days here to count, and I've created one down through 80 days. And the last variable that I've set here is in fact just equal to the variance at the top. Alright, and then my moving, my exponentially weighted moving average is going to be, I'm going to skip up to the top so you can see this a little bit better. Is going to be lambda, which is H1, times the last variance, plus the return for 3M, and that little caret means squared, times 1 minus lambda. So I'll type in this particular equation and hit return, and then go ahead and drag it up. Over here, I'll do the same thing, type in the particular equation, and then drag it up. And as we go through each one of them. Now the covariance matrix is a little more complicated. Again, we've just taken this value at the top and copied it down, set it equal to the value at the bottom. So the covariance is going to be lambda times the previous covariance, which comes from the variance covariance matrix, plus 1 minus lambda times the return of 3M multiplied by the return of DuPont. And these are on the return tab down here. So it's the return of 3M multiplied by the return of DuPont. And you'll notice, to make things a little bit simpler, I've locked in the 3M, so it's $, and I've left the return of DuPont to be variable. So once I have this equation typed in this column, I can go ahead and drag it down until 3M runs away. So I would drag it down through 3M UPS, 3M HD, 3M Procter & Gamble, and stop. Then I'll go to the next column, and it's again lambda times the previous covariance, which again comes from that base covariance table, and it's equal to the this one is equal to the one at the top, times 1 minus lambda times the return of DuPont times the return of UPS. And I've locked in the return of DuPont so that I can drag it over 2 cells and save myself a little bit of time typing. And then we'll just repeat that process. And then we're going to go ahead and drag them out. Now remember that the 80th day, this one right here, represents about 1.6% of the covariance that is at the top. And the variance that is at the top represents roughly 1.6% of the variance that we initially started with. And that's because of that 0.95, that lambda that's going on. And I'll go over that in class mathematically with some algebra just to give you a little better conception of what's going on. So our point estimate, our best estimate of the current volatility in the market, is actually this top row. So what we want to do is now use this top row to create a variance covariance matrix. So this is what I've done for the variance covariance matrix. You'll notice that this value is equal to Ewma B4, which is just the top variance, one right at the top. And that as we go over the diagonal, C4, D4, E4, and finally F4. And again, the easiest way to do this is, and quite simply, is to say that this is equal to, and we go back to our Ewma, we pick our first line item, and then go ahead and drag it across till we see one more. Till we see the zeros. Delete those guys. And then I'm basically just picking this one, dragging it over here, pick the next one on the diagonal, and then I'll build the columns by taking the first column, the first one. Well, I'll go ahead and do it. So that would be 1. These go on the diagonal. So I think you got the idea there, and then we're going to go ahead and build the column. And et cetera, et cetera. So you'll go ahead and build it. Now, one of the things we did before was to highlight a column and go ahead and do Control-C, then come over here, go home, and go ahead and paste. You can't do that here because when you try and do this copy, you'll notice that this is set to Ewma, and that's not what we want. We actually want this particular number. So again, the easiest thing to do, let me delete these guys, is to say that this is in fact equal to this one, and then you drag that down for the entire column. In this case I only have 3, and then just move them over. So that's going to create our square matrix that we're interested in for the exponentially weighted moving average. And I've done that all here with some annotation so that I have an idea of what everything should look like. And we're going to use this matrix a number of different ways. The first thing we're going to do with it is start working on rebalancing the portfolio. So what I'm going to do is the Sharpe optimal rebalance. And I want to highlight here that really the exponentially weighted moving average is used to assess current risk in the market and to decide whether you want to take out insurance, which is futures and options, or possibly rebalancing a portfolio, going from a Sharpe optimal portfolio to your minimum variance portfolio. Would be one example. What it shouldn't be used for is creating a rebalancing portfolio for future long-term investment. Okay? So, and part of this project is to demonstrate the weakness of exponentially weighted moving averages. So we're going to come over here, and what I've done is, and it's pretty easy to do, I'm going to my Sharpe optimal portfolio. Alright, this is the first portfolio that you generated, and I'm on Sharpe 2, which happens to be the Sharpe optimal weighting. And we can confirm that by going to data and clicking on the solver, and you see that we're maximizing the Sharpe ratio. Alright, so what we want to do then is create a copy of this sheet actually into this file. So the easiest way to do that, we click down here and we want to move copy, and it says up here Sharpe optimal. That's not the file that I want. I want variance rebalance, var value at risk and rebalance, and I don't really care where I put it, so I'm just going to click OK, and that's copied that sheet from the other program, from the other spreadsheet, down to the spreadsheet that I'm working on, and it is included. I go back to my data, click on the solver, all the solver materials come along with it, which is good. Alright, now I'm going to go ahead and delete this sheet because we don't need it. Alright, so I've created a copy of that sheet, and what I then did is, instead of using the variance covariance matrix that came with that sheet, I've set this variance covariance matrix equal to the one that comes from the exponentially weighted moving average. And at that point, I can go ahead, remember all of my solver constraints are still here. I have removed the requirement that the beta is between 1.1 and 0.8, and just required it to be less than 1.1. Frankly, I accidentally hit the button and hit delete. So, not purposeful. And we can go ahead and do the solve and go ahead and keep the solution, and it's changed the weights. Now remember, my portfolio weights were originally 47% 3M, 18% DD, 5% UPS, 9% Home Depot, and 20% Procter & Gamble. And now, based on the current volatility in the market, which is a dismal, very low 2.5%, it's recommending that I reweight the portfolio to 26% in 3M, 11% in DuPont, 29% UPS, 29% Home Depot, and 5% in Procter & Gamble. And one of the things that I could say right from the get-go is this 2.5% volatility may be the current volatility in the market, but it is not what I want to base portfolio formation on. Okay, it is extremely low for, in terms of volatility, for the market to have this little risk in it right now. So over the last 80 days, point in fact, the volatility in the market has been very low. And at this point, I also want to emphasize why I picked 0.95 is my lambda, and this is another limitation that comes from the exponentially weighted moving average calculation. If I change this to 0.94, all my spreadsheet completely updates, my variance covariance matrix completely updates, my Sharpe optimal portfolio equally weighted starts to update, and what you can end up with, although it didn't happen in this case, is actually a negative variance. So if we look at our variance covariance matrix, we can see that the covariance has become somewhat negative. Right, minus, minus. And you can have, for short periods of time in your portfolio, negative covariance between the stocks that are in it, the equities that are in it, which actually give you a negative variance. They come close to a negative, or almost zero. And we can't have, there's no such thing as a negative variance. It always has to be positive. Let me see if I, because I picked point, let's go 0.94. Alright. So the problem here is if I actually just sum equals sum and add these guys together, you can see that they're all, or not all, but most of them are negative values, which in fact gives me a negative variance, and I need to take the square root of that, which you can't do. So that's one of the weaknesses of using this particular methodology, is that you can actually end up, depending on your selection of lambda, go back to 0.95, with a negative variance, which tells you that the market has extremely low risk to it, but does not help relative to the mathematics of, it tells you that you don't need to take out insurance on the portfolio, but it doesn't help you if you're going to use it for an estimate to rebalance. All right, so I've gone back to my 0.95. My daily standard deviation is 0.16%. My risk, right? So I'm just taking my standard deviation and multiplying it by the critical value of 2.36. The one-day loss, I'm using the negative of that. The one-day loss is now that minus 0.37 multiplied by the maximum value of my portfolio. So on our port returns, the maximum value is in fact 291,778. So that's the current value of the portfolio, and therefore what I want to look at in terms of value at risk. And then when you do the minimum variance portfolio, you would pick 280. I would pick 282,000. You'll just pick whatever the current value of your portfolio is. All right, so we've gone through and done the rebalancing. You notice that the portfolio beta has dropped to 1.44. We've calculated our value at risk. So because the market right now is very unrisky, standard deviations are extremely low, the value at risk has dropped significantly. It's only 3,400. The 10-day VAR is 3,416 bucks, which is extremely small, and tells you that really you don't need to take out insurance because currently the market has a very low volatility to it. Equivalently, we may have calculated the exponentially weighted moving average and found out that right now the volatility in the market was extremely high, in which case your value at risk would go up, and therefore you might want to go ahead and take out insurance on your portfolio, being future contracts or moving to a minimum variance portfolio. It just depends. This gets back into the art of finance. It just depends on your feeling. Is this a momentary bump in the road, or is this the beginning of a bear market that's going to drop 20, 30, 40%? Okay? All right, so that's our first one. You'll notice that our Sharpe ratio is extremely high at this point, 4.07. That would be great. Our annual return is at 10.46 with the rebalancing. So if you actually believe that the volatility in the market was going to be extremely low, like 2.5% for the next year or two, then this would be the optimal weights for you to rebalance. I would recommend in action that you wouldn't do that. So the other thing we want to do in terms of portfolio rebalancing, this is the variance covariance matrix based on a exponentially weighted moving average. What we're going to do here is go ahead and copy. So I'm just going to copy, move copy, and create a new tab that represents the new an equally weighted variance covariance matrix. So the exponentially weighted is putting more weight on the current volatility of the market, which in this case is extremely low for my portfolio, as opposed to equally weighting all the variances. So what we want to do is create our variance covariance matrix, and since we did the exponential weighted moving average as 80 days. The variance covariance matrix is also going to be 80 days. And you'll go into your data analysis and go, before I do that, make sure I'm not clicking. Go into our data analysis and our covariance. Okay, and then we'll go to our portfolio returns, our returns, and highlight, go ahead and do the labels in the first row and then down through 80. There we go. Labels in the first row, and we're going to output to this point. And I'm not going to go ahead and do it, but you understand at this point how that works. And cancel again. And once we've got the new variance covariance matrix in, we'll have our daily risk. We'll do our solution. And what I want to highlight here, and what one of the points of the project is the vast difference in weighting. So when I'm using the equally weighted returns, I'm at 5% for 3M, 38% for DuPont, 18% UPS, Home Depot, and Procter & Gamble. And over here, it's almost exactly inverted. And both of these portfolios are Sharpe optimal portfolios. So we're still trying to, if I go in here to the solver, we're still trying to maximize the Sharpe ratio. And obviously, our Sharpe ratio has dropped significantly. And that's because even though the current volatility market is very low, over the last couple of months, there's been a lot more volatility in the market. So we don't want to use a exponentially weighted moving average to estimate a variance for optimizing portfolio, because it's taking a look at the current state of the market. Since we're going to hold this portfolio for at least a year before we rebalance it again, typically, you want to use exponentially, or you want to use equally weighted variance covariance matrix, and you probably would want to use more than 8 days or 80 days. If you're going to hold it for a year, you might want to use at least 252 days, maybe even more than that, just to get a better picture of what's going on in terms of the market. All right, so and then in your project, you're going to have to do this same step for your Sharpe minimal, your minimal variance portfolio as well. And then what you're going to need to do is create a table that compares the weights for the Sharpe optimal rebalance in terms of equally weighted, the rebalance weights for the exponentially weighted moving average, and then your original portfolio weights. So you'll notice we're at 47, 18, 5, 9, and 20, and our Sharpe optimal based on the last 80 days equally weighted returns, we're at 5, 38, 18, 17, and 22. And our expected, our predicted return is 10.98. Our volatility is at 11.2, and annualized volatility. I'll just highlight this too. Since I'm using daily returns, I have a daily variance, so I have to multiply up here by the square root of 252 as opposed to the square root of 12. I didn't do that. Okay. That is the basic process for using exponentially weighted moving averages in terms of doing the calculation. As your lambda goes up, you're going to need to include more historic data. As lambda goes down, you can actually include less historic data, because the past values have less and less impact. Long run, past values have less and less impact. Alright, so that is this, and we will go over it in class as always, and you'll have your video to take a look at. Have a good evening.